The next question is question 21, and this question says a copper rod 5 meters long, L1 equals to 5 meters. When heated to 10 degrees Celsius, expand by 1 millimeter. So delta theta equals to 10 degrees Celsius, and expansion is equal to 1 millimeter. If a second copper rod 2.5 meters long, L2 equals to 2.5 meters long, is heated to 5 degrees Celsius. So delta theta 2, we can say this is 1, this is 1. Delta theta 2 equals to 5 degrees Celsius. By how much will it expand? So we are looking for expansion 2. So E2. So if you recall, from here we have that if we look at our expansion, we know that alpha equals to expansion over L1 delta theta. So alpha 1 equals to expansion over L1 delta theta, and alpha 2 also equals to E2 upon L2 delta theta. But since it is the same material, both of them are coppers, that means alpha 1 is equal to alpha 2. So if we have alpha 1 equals to alpha 2, that implies this E1 over L1 delta theta equals to E2 over L2 delta theta 2. So if we cross multiply, here we are going to have E2 L1 delta theta 1 is now equals to E1 L2 delta theta 2. So when we divide by L1 delta theta 1 here by L1 delta theta 1, this cancel. We now have E2 equals to E1 L2 delta theta 2 over L1 delta theta 1. So by making substitution here, E2 will now be, our E1 is 1 times L2, we have 2.5 times our delta theta 2. Okay, delta theta 2 is 5 divided by our L1 is 5 times our delta theta 1 is 10. So if we look here, 5 cancel 5, 2 times 2.5, we now have 2.5 divided by, okay, we can say E2 is now equals 2 times 2.5, we have 2.5 divided by 10. When we divide 2.5 by 10, is the same as taking this point backwards, so it's 0.25 millimeters. If we look at our options, in our option B, we have 0.25 millimeters. The answer is B. You can hold on the, whenever you have a step that you don't understand, you can hold the video, look at the step, then replay it again. The next question is question 22, and this question says, the ratio of the coefficient of linear expansion of 2 meters, alpha 1 slash alpha 2 is 3 is to 4. So alpha 1 over alpha 2 is equals to 3 is to 4, which is the same as 3 over 4. That means alpha 1 is equals to 3, alpha 2 equals to 4. Or let's write it, alpha 1 equals to 3 and alpha 2 equals to 4. Okay. If when heated through the same temperature change, the ratio of the increase in length of the two metals E1 over E2 is 1 is to 2. So E1 over E2 is equals to 1:2, which is the same as 1 over 2. That means E1 equals to 1 and E2 equals to 2. The ratio of the original length L1 over L2 is, so we are looking for the ratio of the original length L1 over L2. So L1 over L2, that is what we are looking for. Recall that we said alpha equals to E over L1 delta theta. We make L1 the subject, bring it here and bring alpha here. We have L1 equals to E upon alpha delta theta. So if we now substitute these are for L1 of this one, we are going to have L1 over L2 will now be L1 we said is equals to E1 over alpha 1 delta theta 1. If we divide it by L2, we now have over E2 over alpha 2 delta theta 2. So this one we take reciprocal. We have L1 over L2 is now equals to E1 over alpha 1 delta theta 1 then times alpha 2 delta theta 2 over E2. So delta theta are the same. Delta theta cancel delta theta. So we are now having L1 over L2 is now equals to, okay, E1 is equals to 1 over alpha 1. We have it to be 3. Then times alpha 2. We have it to be 4 here over E2. We have it to be 2 here. So over 2. So dividing this one, okay. So if we look here, 2 here, 1, 2 here, 2. So we now have finally L1 over L2 equals to 2 over 3. So if we look at our option, in option C we have 2 over 3. The answer is C. The next question is question 23, and this question says the ratio of the linear expansivity of copper to that of iron is approximately 1.5. So alpha of copper over alpha of iron is equals to 1.5, and this 1.5 is the same as saying 3 over 2. A specimen of iron and specimen of copper expand by the same amount per unit rise in temperature. The ratio of their length is, so in this case, expansion of copper is the same as expansion of iron. So we are asked to look for the ratio of their new length is, so if you now look at it, expansion of copper, expansion, we said expansion E equals to alpha L1 delta theta. So expansion of copper, we now have expansion of copper to be equals to alpha of copper, length of copper, delta theta of copper, since the delta theta is the same, is now equals to expansion of iron. We have alpha of iron, length of iron, then delta theta. So we can relate these two. Delta theta can cancel delta theta. So we are now having alpha of copper, length of copper equals to alpha of iron, length of iron. So for this case, if we want to get length of copper over length of iron, so this one we now divide it by L1 alpha of copper, here also by L1 alpha of copper. So that means alpha of copper cancel alpha of copper, and then length of iron cancel length of iron. we are now having length of copper over length of iron equals to alpha of iron over alpha of copper. So this one, if we look here, alpha of copper is 3, alpha of iron is 2. So we can now say this is the same as 2 over 3, which is the same as 0.67. So this one can give us 0.67. Or this one we can change it. If we look here, we can also say L of copper over L of iron equals to alpha of iron over alpha of copper. So from here, alpha of copper over alpha of iron is equal to 1.5. But if we take the inverse, alpha of iron go up, alpha of copper come down, we take the inverse of this, which is the same as 1 over 1.5. So, and this also gives us 0.67. And if we look at our option, we have it in option C, we have 0.67.